Hello everyone and welcome to a video on metals. This video covers metals on a basic level and I don't dive too deep, but that's okay because you don't really need me to right now. If you would like me to dive deeper in this topic, then leave a suggestion in the comment section below. Alright, let's get started. So we use metals to build and shape the cities that we live in. We use metals to even build and construct our houses and our homes. We use metals to make our cars. We use metals to make our airplanes. We even use metals to make our phones. We have metals everywhere in our appliances, in our homes. Heck, metals shape most of our daily lives and shape the world we live in. But what exactly are metals? So, metals are materials that have metallic properties. But, Mr. Top, can you ask, what are metallic properties? Well, that's why you're here, because I'm going to show you. So, at the heart of it all, the the heart of metallic properties has to be lustrous, or the property of being lustrous. Metals are extremely lustrous materials. If you just lustrous is that shine that only metals have, that metallic shine. You cannot mistake any material for being a metal or being lustrous, and it's not a metal. Because if you take a look at that shininess, let me use my laser. That shine that only metals have, that is the lustrous property of metals. It's kind of why metals get our attention like more than non-metals because they're just shiny and they grab our attention because they're so shiny. All right, and that's the lustrous of metals. The next big property of metals or metallic property is that they're conductors, not just conductors of heat like these pods over here, but they're also extremely good at conducting electricity, like the copper wire we can find in our wire cables, right? Our electrical cables. Metals are also very malleable, right? That means that they can be hammered or bent into different permanent shapes without breaking. So you can, in this image here, we see iron being made into a very intricate shape. We also see that here it shows how a ball of gold can be made into a flat disc or coin. That is the property of being malleable. Then we have the property of being ductile. Ductile means that it can be stretched into thin wire without losing too much of its strength. Um, it also means like it doesn't basically just snap. Non-metals tend to, if you stretch the non-metals too far, especially if they're not elastic, they tend to just snap at a point. But metals sort of get drawn out, so the atoms stretch and they form a thinner shape, but they do not lose their tensile strength. So that's ductility. Then we have the property of being sonorous. That means that they're able to have a deep ring in the material, like a deep ringing sound, kind of like when you ring a bell, right? That ring that only metals can do. Uh, it's a sort of prolonging or amplification of vibration through the material, and that is the property of being sonorous. Other properties that metals have, they're not as core to metallic properties as the ones we've seen before, but most metals are strong. Not all metals, but most metals are strong, like in titanium being the strongest. We have the property of being hard. Hard means that it's not easily scratched or cut, and no metal is harder, or no natural metal is harder than chrome, right? You can see how smooth it is because how difficult it is for it to be scratched or cut. And we have the property of being ferromagnetic. That means that the metal material is attracted to magnetic fields. Most metals are not ferromagnetic. The four that are cobalt, nickel, iron, and steel. And steel is just ferromagnetic because of the iron, so it's actually just three that you've learned about. So that the attraction to a magnetic field means you are ferromagnetic, and that's typically what metals have. I'm not saying that there's no non-metals that have it, but it's mostly metals that are ferromagnetic. All right, I've summarized those properties in this table form, and I've added the non-metals here on the right. So if you compare them, you can see metals are lustrous, they're good conductors, they're malleable, they're ductile, they're strong, they're hard, they're ferromagnetic, whereas non-metals are pretty much the opposite of that. They're dull, they're insulators, brittle. I mean, brittle is the opposite of tough, right? But the non-metals break easily. They're weak. They can't support as much stress, or they can't have as much weight as not as metals. Of course, there's exceptions to this rule. They're soft. That means they're easily cut or scratched. Again, exceptions. Diamond is a non-metal, and that's the hardest material in the universe that we know of. But most non-metals are soft, and they're versatile, meaning because they can be used to make a lot of different things, and one thing can be used to do a lot of different jobs. I mean, if you just look at crude oil, it's used to do so much and make so much different materials, right? Just from that one material, it's changed in so many ways, which is why we say it has the property of being versatile. All right, this is the part of the video where we do a speed run through the different types of metals, and I talk about like their most redeeming, or their most powerful, or their most sort of highlighted property, and then we talk about how we would use that in an everyday sort of practical use. So titanium is very strong. It's the strongest natural metal. It's used in many different ways. In this case, it's used to make prosthetics. So if you've damaged your bones, or you've lost a leg, perhaps, then they can basically create a sort of replacement bone out of the metal, which would be way stronger than the calcium metal that's in your bones right now. So titanium, also because it doesn't corrode easily, so it's great for keeping inside someone's body, because you don't want a metal that will basically corrode in your body, then poison you. So titanium is a good choice for that. And then we have aluminium. Aluminium is extremely light, but also very strong. So it's excellent choice for making aircraft or any flying vehicle, which is why we use it in airplanes and helicopters. This is because let me go back. I actually forgot about that. But Americans say aluminum. It's actually, I mean, it's aluminium, because there's clearly an I here. And so the reason why I put this here is because I've heard my learners say it, and it just, sometimes when I think about how you leave the I out, I just think the I feels this way. All right, I digress. Let's move on. Chrome. Chrome is the hardest natural metal. Very difficult for it to get scratched or cut. In fact, it has having a hardness of 8.5 on the scale of hardness. Only itself and something harder can scratch or cut it. Iron. Iron is a very useful metal. In fact, a lot of alloys, which is mixtures of metals and other metals or non-metals, are made from with iron. Like steel, for example, is one of the most used metals in the world, and 98% of it is iron. Of course, iron, is ferromagnetic, so it's attracted to magnetic fields. All right, cobalt, another ferromagnetic metal. Cobalt is very ferromagnetic, which is why we use it to make magnets a lot. Nickel, very hard, also ferromagnetic metal, used to make coins because it's so hard. So the coins, the engravings don't get damaged or scratched off in a short period of time. In fact, it takes a long period of time and a lot of friction for it to eventually get scratched off. Copper, an excellent metal because it's so ductile, it's so malleable, and it's such a good conductor of electricity, which is why we use it in copper wire. I mean, electrical wires. Then we have zinc. Zinc is used to galvanize iron because zinc does not rust like iron does. Zinc is used in a process called galvanizing to protect the iron from being rusted. And we have silver. Silver is one of those very luscious metals. It's extremely shiny, which is also why they make jewelry out of silver. Silver is the best conductor of electricity, but it's not useful in that field because of how easily it can corrode in certain conditions, or in the conditions that would be in that field of work, like in electrical wiring. So because it corrodes and it's heavy and expensive, it's better just to use copper. But silver is a very good electrical conductor, very lustrous. Tungsten. Tungsten is has an extremely high melting point, higher than any other metal naturally. Above 3,000 degrees Celsius, it only melts above temperatures above 3,000 degrees Celsius, which is also why initially they use it to make light bulb filaments, because this thing gets very hot inside the light bulb. and most metals would melt, where tungsten doesn't even is not even bothered by that heat. All right, then we have platinum. Platinum is also known, or rather, I call it the forever metal, because it just does not corrode. Where other metals have that vulnerability, platinum, it doesn't corrode. It doesn't. It's not affected by acids. It doesn't get affected by oxygen. It just doesn't. Pure platinum is literally forever. It will not tarnish, which is also why it's so expensive and so useful. Right, gold. Gold is extremely another lustrous. By the way, both platinum and gold used in jewelry. Gold more than platinum. It's been with humans. Humans have been using gold to make jewelry for thousands of years, and we're not stopping. Gold is malleable. It is ductile. Uh, it is very useful. Again, like platinum, similar to platinum, it doesn't corrode very easily, but there is conditions where it can corrode quite easily, but not on just not like everyday conditions. Very specific type. Also, gold is very heavy and also surprisingly soft for metal. Then we have mercury. Mercury is the exception because most metals are solids, where mercury is a liquid at room temperature. Um, yeah, there's always that one that has to be different. So that's mercury. As you can see here, there's a better picture of what mercury would look like if you had to put your finger in it. Yeah. So then we have lead. I think lead is the last one on in this video, but lead is a very dense metal. It doesn't allow radiation to pass through it, so it's used as a radioactive shield, or sorry, a radiation shield, um, to protect people from radiation damage. And also, you can see it here. This is what lead looks like as a metal. It's very soft for metal. You could actually cut it with a knife quite easily, actually. So yeah, that's lead. All right. So I hope that you found that useful. I hope you found that, um, you know, like enriching, and I hope you never stop learning. Stay awesome. Till next time. See ya.